this it?
Deep in the Amazon rainforest, a team of scientists is stalking some unusual creatures by some unusual means. They are tiny insects of infinite complexity and astonishing design.
We're not hearing it, but this whole field is just a carpet of sound. You get this weird sensation of an alien world of sound.
Bizarre, fascinating expressions of life in a bug world that defies our imagination. These are the mini monsters of Amazonia. It's only 300 kilometers as the crow flies from Quito, Ecuador to Yasuni National Park. But in this land of mountains and narrow winding roads, driving to the headwaters of the Amazon takes a nerve-wracking 15 hours. The expedition has been organized by Stuart McCamey of the Systematic Entomology Lab of the U.S. Department of Agriculture. Joining him is biologist and research associate from the Royal Ontario Museum, Nick Tatarnik.
I would always jump at an opportunity to come to the tropics. We're guaranteed to find something that we don't know. Every time you wake up and step out the door, there's something different out there.
Author, teacher, and research scientist Carolina Godoy is from Costa Rica. Patrick Landman, a French photojournalist, is also a tree climbing expert.
Is that a bunter hitch?
Like countless expeditions before them, this team is seeking treasure. But their treasure is a bizarre-looking insect that has captured their imagination. But they won't be alone. Oil is big business here, and it controls scientists' access to the region. There are an estimated 1 billion barrels of crude oil lying beneath the forest floor of Yasuni. Many fear that further development could jeopardize this delicate ecosystem and the lives of the people living here.
Vamos, maestro.
Here we go. And then about a half an hour later, they say, when are we going to get there? And he just leads them along little by little. And just when they're at the point of mutiny,
Since guerrillas from neighboring Colombia kidnapped oil workers living in the park a few years ago, security has become a huge issue. Now, everyone must agree to abide by the oil company's strict rules in order to enter the park.
okay, you can't film here.
No.
For many, a trip to the Amazon is a chance to get close to exotic creatures that fuel our imagination. But not so for this team. They are charting a new frontier. They're looking for a tiny piece of the natural world, insects called membracids, commonly known as treehoppers. They are difficult to see and even harder to catch.
We want to discover more species because the more species we find, like missing links in the study of human evolution, the more we can find out and complete that picture of our world and this ecosystem in particular. We have no idea what we're going to find, and that's the exciting part.
Bosidium. Great.
This is Bosidium, only 6 millimeters long. It's just one of the more than 3,000 species of treehoppers that have been identified since the 1700s.
No one really knows how many species there are. There was some recent studies near this area that have found just in a small number of hectares over 300 species of treehoppers. The described species for all of South America is about 800. So what are the odds that almost half of that is going to be in just a few hectares of Ecuador? Surely there are a lot more species than we know.
Growing out from Bosidium's back is a wild-looking appendage called a pronotum. Its purpose is still very much a mystery. A macro scanner allows us to see it for the first time in a new way. It's thought that they may use the pronotum to navigate by smell or touch. But because it breaks off easily, perhaps it could provide protection from a predator that would find this thorny spike difficult to swallow.
As an evolutionary biologist, I'm interested in morphological diversity, why things look weird, and treehoppers definitely fit the bill. They're some of the weirdest looking insects you'll ever see. And one of the big questions is, why do they look the way they do? Why do they have all these structures? Why do you have so many species in one small area? How are they partitioning the environment? Are they all feeding on the same thing? Are they feeding on different things? Do they recognize one another? Do they make mistakes and interbreed? How do they keep apart?
With a jungle full of vicious stinging wasps, poisonous snakes, and a floor covered in armies of biting ants, working here would be a real challenge without a knowledgeable guide like Humberto Aua to show the group around. He's a member of the Guarani tribe. Some of them continue to live isolated from the industrialized world, even today.
There he is.
Do you have an egg?
What's that?
He's going to jump using it.
No, I can do this. Well, I found that there's a lot of treehoppers around here. They're really hard to find. You know, you gotta keep your eyes open. You can't blink, or you're gonna miss them.
Una ninfa. Lo que hago es primero buscar en la
The first thing I do is check the leaves, the plant's joints, and on the stem.
Y si hay
If there are ants, that helps me to find them.
This is how Carolina Godoy loves to spend her time. She's written the world's only treehopper field guide, a Bible for working scientists.
no sabemos exactamente.
We don't know exactly why membracids prefer certain plants. Possibly it's due to the type of nutrients the plant has. We know they nourish themselves with phloem, and in the phloem they're going to find nitrogen, amino acids, water that they need, and the carbohydrates that they use to nourish themselves.
Se alimentan.
Although we have diverse plant life in the Amazon, membracids prefer certain families. For example, they prefer Sigia, they prefer Inga, and we can find genera like Umbonia and Symbomorpha.
Membracids have been around for 40 million years. But we are just beginning to understand how these remarkable creatures have survived and flourished. All treehoppers feed only on the sap of living plants. They use a stylet, a pointy extension of their mouth, to pierce the plant's flesh, and like a double straw, the stylet has two channels. One side injects saliva into the plant, while the other draws in nourishing fluids. Their saliva contains enzymes that help to digest plant tissues and protect the stylet from being damaged. The host plant is not just a source of food, it's also a perfect place to hide. The intricate shapes and colors of treehoppers make them hard for predators to find, and that goes for scientists looking for new specimens.
There's so many different shapes of treehoppers, literally, that you just have to look for any irregularity in the plant to find them. People don't even know they exist because some blend in so well and they just aren't looking in the right place or don't know even to look.
Photographer Patrick Landman is obsessed with membracids. He travels the world in search of them and has taken thousands of unique images.
I discovered these insects while reporting in Guyana. A biologist showed me his private collection. They were superb. When you see them through a lens with a powerful zoom, it's marvelous. You see details appear and they express such poetry. It's absolutely fascinating to see them like that.
Oh, look at this. Gorgeous.
Oh, wow, that is. Those are the
Gorgeous.
city on the top. That is awesome.
Digital images taken in an environmental scanning electron microscope reveal even more details and bring new questions.
Fantastic images here. I've never seen them so close up. Look at these. Compound eye. Just incredible.
Beautiful.
And these are the simple eyes,
Wow.
equidistant from the compound eye to each other.
And those just see light and dark kind of movement?
Yeah, those general light receptors, they can't form images with those, but they can sense light. The compound eyes are made up of hundreds of facets. No one really knows if they see multiple images or if their brain processes all those images into one, like our brain processes the images from two eyes into one image. And I don't think there's any way to really determine that.
Obviously, their eyesight is good enough when you try and catch them.
Right,
they
they're
get away.
fast. A lot of the membranas have contrasting blacks and whites and yellows, oranges, reds, which are classic warning colors in the animal kingdom.
So, would you guess that they taste bad?
I haven't tasted them yet, but yeah, I'd guess that they taste bad. And what birds learn from snakes and other insects, they probably see these and make that immediate association in their brain and avoid eating these as well.
High up in the canopy, there is tender new growth and nutrients are abundant. Good treehopper habitat. But so far, most treehopper species have been found on plants growing near the ground because that's where most scientists look for them. The team is keen to search the treetops. But first, they must find the perfect tree.
Man, that's one big tree.
Yeah, indeed.
So you reckon we're going to climb that?
Yeah, I think so.
Yeah.
I think that there must be some trees around. If you can
but
go
I mean, how
shoot
high do you
down.
think that branch
Yeah.
is? I think
Should
that's
be-
20 meters, 30 meters.
Yeah.
And you know what? You go first.
I think they're squirrel monkeys. Roberto spotted them first, of course.
Although their chosen tree stands tall above the canopy, once they enter the dense forest, only Umberto will be able to find it again.
Moneta bastante pica.
Oh, yeah. There's a huge wasp nest, like a human's height. Pica?
Sí,
See?
duro,
Yeah.
duro.
Damn.
Yo tapero todo.
Well, at least we saw it now instead of when we were up there. I'm not going near that. I guess that's what happens when you're in a rainforest. Things live there. Is this it? It's huge.
Yeah. Oh yeah, that's really a big one.
Umberto, how tall? Look at this thing.
How old would it be?
Oh, it's hard to tell. With rainforest trees, there's no seasons. So there's no growth rings to count. So, I mean, it could be a few hundred years old. It could be more than a few hundred years old.
Oh yeah.
Who knows? Does it hold our weight?
Yeah, of course, no problem.
Except for this. You know, Stuart doesn't think we're going to catch a lot of tree hoppers up here in the trees, up in the canopy, but when you're in the rainforest, a lot of the plant growth occurs up top. If you look at this tree, you know, there's no leaves down here. The leaves are up at the top, and the tree hoppers like new growth.
Even for these experts, getting into the canopy is proving to be quite the challenge.
This isn't going to be easy. No.
Nick and Patrick can't even get their first climbing line over a branch.
Close.
Getting up this tree will require a different strategy. Here, there is a world of hidden complexity waiting to be discovered. Surprisingly, there's even cooperation between species. In return for protection, treehoppers allow ants to eat a sweet liquid they excrete, honeydew. The ants stroke the treehoppers with their antennae, so the treehoppers release the tasty liquid. But for some species, ants are a threat. The mother of these young Ambonia makes it clear that she won't tolerate them near her nymphs.
These are Azteca ants that have built enclosures using little bits of soil around the treehoppers, so that the treehoppers can't escape, and that way they have a guaranteed source of honeydew. It's basically made a prison for the treehoppers. The treehoppers are at the mercy of the Azteca ants, and if they don't produce, they might get eaten. Yeah, boy, this is probably going to fall apart if it rains as hard as it sounds like it. I hear thunder in the background. Better collect and get out of here fast.
Over millions of years, the rainforest creatures have evolved to cope with their often unpredictable home. Here, sudden storms can make rivers swell 3 meters in just a few hours. The hot and humid conditions that challenge the team have produced a myriad of beautiful and strange adaptations. But for the team, each day brings its own challenges. Hordes of tiny biting creatures in their never-ending search for a tasty meal get past layers of clothes and potent insect repellent.
Oh my God. You need to take off because it transmits disease. Sí, una infección.
Patrick is a victim of a potentially dangerous tick that has bored into his skin. Only days after copulating, this Ambonia treehopper is ready to lay her eggs. She uses her ovipositor to make incisions into the stem, where she lays dozens of eggs. The eggs are covered by a protective wax-like coating, and she'll guard them until they hatch. Scientists think that the females release pheromones, a chemical message to attract other females to lay their eggs nearby. By increasing their numbers, they reduce the risk of predation. A tiny parasitic wasp doesn't look like much of a threat, but she is a treehopper's nightmare. Female wasps look for freshly laid eggs and then lay their own inside, most certainly killing the treehopper embryos, but for the young wasp, it's a nutritious and safe nursery. These darker yellow eggs have already been parasitized. The Tiputini River forms the northern boundary of Yasuni National Park, a UNESCO Biosphere Reserve since 1989. It's home to the giant anaconda, caiman, and a huge variety of fish, including piranha. It's also a highway for people.
But look how high the water level goes when it floods, 2 or 3, 4 meters up.
Yeah, it's incredible.
Yves Pacalet, a French environmentalist, writer, and philosopher, has joined the expedition. He spent 18 years traveling with the naturalist and filmmaker Jean-Jacques Cousteau. In the early 1980s, they spent 2 years exploring this vast region.
Pas deux rivières qui ont le même goût.
No two rivers taste alike. No two rivers share the same color. This one's a bit earthy, with organic particles. The waters of the Amazon are split in two, the black waters and the white waters. If you mix rivers with black water, water which is very rich in humus, with white water, very rich in minerals, life literally explodes. These are the most amazing, the most beautiful spots in the Amazon.
We already know there are at least 3,000 treehoppers in the world, and at a rough guess, there are about maybe 10,000, which would be more treehoppers than there are mammals in the world.
That might sound like a big number, but when you weigh all the insects in the world and you compare that to everything else that's living, they weigh more than everything else. So to say that there's 10,000 species of treehoppers, that might even be an underestimate.
Right,
there could be more.
Especially considering the diversity of plants. There are hundreds of species of trees alone in this area.
So there could be a rare little species sitting here right at the side of the river that we've never looked at before, and maybe there's a species of treehopper, maybe there's 2 species that live only on that plant.
Oh, look, the Symbomorpha nymph.
Oh yeah, nice. Looks just like a leaf.
Cute little guy. It also looks nothing like this at all.
At another research station downriver, everyone gets a bird's eye view, the easy way. It turns out to be a treehopper gold mine and makes them even more eager to climb a tree in their own area.
Lots of treehoppers up here. And lots there.
Are you going to reassess what you said about us catching stuff in the canopy?
Yeah, well.
Here's some adults underneath.
Oh, there's a mixture of species here.
What do you have?
Aureola. Is this it? Late in the story, mature, and 10 more ants biting my hands.
It's easy to get carried away and forget that there's a 4-hour boat ride home. As they're about to leave, another torrential downpour delays their return for hours. Now they have to motor back in the dark. It's a dangerous journey, only possible with Umberto and his son.
Why not get until midnight?
Honestly, I thought we'd be staying at the station. I thought that the rain wouldn't stop.
It's fantastic. It's like a science fiction film. In the forest, like Conan Doyle's The Lost World, looking for dinosaurs. But the dinosaurs are little treehoppers.
And like the dinosaurs, these tiny, strange bugs still have their secrets.
We spent the whole day trying to shoot a little tiny slingshot, try and get our line up. And every single time we were coming within a meter short of the branch. So today, I've got an 8-foot pole and a big, big slingshot. So we'll probably be able to shoot right over the tree now. Shooting. Nope. And shooting. Oh, fuck. Look, it's already tied itself into a knot. Nope. Umberto, how did you get there? Did you go up this one here? No rope, just rubber boots and a little piece of string. Umberto's a natural-born tree hopper. Wow. You make us look terrible. Stuart, can you tell Umberto that we've come to realize that our technique is no good, and we're going to ask him to climb up with his piece of string and throw our rope over top, and then we can climb up and pretend that we did it, you know, all cool. Okay, no problem.
On a branch deep in the forest, the birth of another family of tree hoppers is about to begin. Two weeks after they were laid, the eggs hatch. In these conditions, it takes the minuscule nymphs about an hour to emerge.
Treehoppers are a lot more complex than we give them credit for. But as you start to examine them a lot longer and take the time to see what's going on, you realize there's interaction between the sexes, there's interaction with other species, there's defensive behavior, there's courtship, there's singing. It's a complex world, and I find that really impressive.
Unlike other insects, tree hoppers molt 5 times before finally becoming adults. Here, it's a month-long process. Within an hour, this young adult assumes a completely new identity, Membrasus foliata. It's no longer an earthbound nymph. Now, it can fly and will live for 2 to 3 months. Left behind is the shell of its former self. One thing that fascinates scientists is how creatures, including insects like tree hoppers, communicate. Rex Cockcroft from the University of Missouri-Columbia is a world expert in this field. He's developed a technique that allows him to eavesdrop on a secret world that uses vibration to communicate.
I'm recording the sounds of these member acids that will travel through the plant stem that they live on. So it's a very simple process. We take a section of the plant, we attach a phonograph cartridge or another kind of microphone that makes contact with the plant that will allow us to pick up their vibrations. We send that through an amplifier and then into a tape recorder, which then allows us to download this onto a computer and look at their signals where we can analyze them and compare them to other kinds of signals. Treehoppers are very communicative, but they communicate with vibrational signals that travel up and down the stems and leaves of their host plant. So they create the signal using their body, travels through their legs, and then other member acids that are on the same stem can pick this up. Wow, it's a fantastic sound. Nobody's ever heard that sound. You could be sure of that. There's a whole forest full of insects that are signaling using incredible sounds. They're monitoring their environment, they're communicating with each other, and so there's actually a huge amount going on, and if you watch them, you might think absolutely nothing's happening, but once you can tap into that vibrational world, you realize there's a whole series of interactions that you're completely missing.
A stink bug in search of a meal gets everyone's attention. Nymphs are particularly vulnerable.
When a predator attacks, the individuals closest to the predator will signal, and the signaling travels in a wave through the group. So everybody's signals pile up into a kind of vibrational shout. Now, when the mother hears this, she immediately responds. She approaches the group and she looks for the predator. She can kick, she can buzz her wings and try to drive the predator away. A very recent study showed that treehoppers can actually communicate with ants. When mothers of this treehopper are defending their young against a predator, the mother produces a series of little signals, and if you play back those signals to ants, the ants respond and approach and can then find the predator and evict it from the plant. Given how incredibly important ants are to treehopper biology, and how incredibly many species interact with ants in the Amazon, this kind of behavior, this kind of interspecies communication of treehoppers talking to ants is probably very common.
Let me get these on. That's hilarious. Wow.
People wouldn't think of insect songs as beautiful, but I think you could use
It's like
that
whale
term.
music almost.
So we'll go from sublime to ridiculous.
That is ridiculous.
This one's a little bit longer, but hang on there. There's a real punchline at the end.
Wow. Aliens have landed. That's incredible.
Sí. Como periqui.
Ajá, sí. Sí, chillan como periqui.
Ya, moneta.
Ajá.
Sí. Ese abuelo nosotros como radio.
Sí, sí, una radio ahí.
Sí, llamando de vecinos, ya viene vecino nomás.
Pero esto es para cacería.
Sí, cacería.
para llamar a la esposa que traiga cosas para cocinar.
Sí.
Y por eso es porque Humberto was explaining to me how the Waorani use these trees to communicate, and they use a special kind of tree for a special kind of message. So this tree that he was demonstrating for us is used to announce that you've gotten food. You're a hunter and you're coming home with game. There's another kind of tree that they use for neighbors to announce that they're coming to pay a visit. It's really interesting to see how these parallels between how the Waorani use plants to communicate and how the treehoppers that we've been talking about also use plants to communicate. They might also announce we've got food or we're coming to visit.
With the treehoppers, they don't hear each other until they're sitting on the same plant. So there's this big question that we don't know the answer to, is how these things find each other. How do these find a mate? We don't know.
Grab a handful, take a line.
The team lays out 100 square meters of nets to collect insects living high up in the trees.
Bloody hot here.
And we're just doing a simple bow on each, Nick, so that they can be undone with one hand. We'll be fogging the canopy with insecticide. The fog will rise into the treetops, and then the insect rain will come down from the trees.
It'll knock out all the bugs. It won't hurt any vertebrates, any of the other animals, and then we'll catch what falls.
The fogging allows the scientists to estimate the density of different species of insects in Yasuni.
Carolina, what would this be? It's different from what we've seen on the ground so far. I know we haven't
New one
seen
for
it.
me, beautiful.
Cool, Omelon.
Here we have the infamous bullet ant. It's also known as a 24-hour ant because the pain is supposed to last for 24 hours. Bullet ant because it feels like getting shot with a bullet.
I know it may seem cruel, but it's like plucking a grape in a vineyard. Only here, within a month or two, it'll be full of life again. Ah, insect treasure.
They've collected more than 200 species in the nets.
Oh, this is one of the bullet ants.
After carefully identifying where each was found, Stu and Carolina put them in a preservative. There's lots more work to do on classifying them back home.
Ahí está una rama.
Finally, the intrepid climbers get their bird's eye view.
You're here. So here I am about 40 meters off the forest floor. Right after getting up here, I've noticed 3 different species of membracid. I've seen species of Cladonota that we haven't collected at the ground. We found some Trigona bees tending membracid nymphs. The forest isn't homogeneous. There's countless species of tree out there, and each tree species potentially harbors its own little ecosystem of insects.
there, get it. All right, woo! New genus for the trip. Great.
Uy, la medianoche y yo quiero ir a la cama. Hasta luego, estuvo allá me voy. Bye, bye.
Bye, good night.
Yasuni is a wild place, even by the Amazon standards. In just 2 short weeks, the team found 70 different kinds of treehoppers, including a new species. And that's just the beginning. The unexpected and extraordinary world of tiny treehoppers gives us tantalizing hints of a world far more complex and diverse than we could have ever imagined.
Scientists find all kinds of theories, but in a deeper way, it addresses the question of Darwinism. Meaning it's not a great battle where the meanest eats the others. Membricids practice deception, impersonating plants, impersonating animals. The law of the jungle is not the law of the jungle. The law of the jungle is the law of community, the law of association.
As biologists, I think all of us, we're all driven by questions and searching for knowledge. You know, if we lived 100 years ago or a few hundred years ago, we'd be explorers of some sort. But instead of exploring the globe and trying to see if the world is round or flat, we're exploring how things live and why they do what they do and how they came about. Every organism in its own way is special. I think that they all deserve to be studied. We could have easily been studying slime mold or mushrooms. Treehopper is one vehicle that we can use to learn more about the environment, to learn more about evolution. Is this guy under the leaf here too?
Yeah.
The questions that come out of working on any living thing, the more you look at it, the more complex you realize it is. There's a lot going on here that no single researcher is ever going to figure out.